Hey guys, so today we'll be discussing a question which was asked in the company DataBricks. So let's try to understand the given question. The question says that we need to find the minimum distance to visit all the nodes of a undirected weighted tree. Now, what you have been told is that you are given a tree. Now you have to visit all the nodes. So when you're visiting all the nodes, just remember that there are a couple of things which we need to account for. But before that, let's understand few of the terminology. The terminology first is undirected. So undirected means that if we go from node A to node B, it also means that we can go back from node B to A. That is one thing which you need to remember. And weighted means that every edge has some weight associated to it. So from edge A to B, that has a weight W1, and similarly B to C has W2, W3, and I'll write for remaining. I hope that is clear, and I hope the meaning of weighted and undirected is clear. Now we have to find the minimum distance to visit all the nodes. Now let's when we talk about visiting it, you need to remember that when you visit some, okay, let's take a very basic example. Okay, your mom told that okay, you have to distribute some letters to your some of the family members or some relatives which lives in different houses. Let's say that A, B, and C. Okay, so it will be like you started from your home at this point, and you said that okay, I will visit A, then I will visit B, then I will visit C. So this is a contiguous path. Okay, what I mean to say is that when you're visiting, it's always contiguous. It's not like you visited A and all of a sudden you started to visit B or some random thing. So that is what why I'm telling you this example is that it will come very handy. Okay. So let's try to read the question further. Now it has been said that the weighted tree has n nodes and the n nodes starting from 1 to n, and the node 1 is the source. So yeah, assume A to be source or your node 1. Okay. And the task is to visit all the nodes of the tree with the minimum distance traveled. Okay. So let's try to understand what this question is saying. So let's start from some point. I'll to choose a different color, maybe. Yep, this will do. So I started from A to B. I went to B, then I went to C. Now remember what I had told you earlier. If I'm visiting my relatives, it's not like all of a sudden I'll go to D, right? I mean, I will have to have a path which will help me to either I can. So what I can choose is that from A to B to C, I can go back to my home and then go back to D. But do you think while doing this, this would become a like this will actually make sure that the whole traversal path is minimized? No, right? So what might eventually happen is that we go to node A, we go to node B, we go to node C, but we go back again. And then after reaching point B, we go to the node D, and we have arrived at D. So same thing over here. Now we need to travel the E, right? So we need to go back to a node A. And after reaching node A, we'll go to the node E. And same thing applies over there on the right hand side. So something similar must be done. That is very clear to you, right? But how do we actually make sure that this is the minimum? Yep. So one thing before that, one thing you can observe is that every edge is being traveled twice. Do you agree with me or not? Do you agree with me or not if the every edges we are traversing twice? Because in doing so, we are going through the all the nodes. So you might tell me that hey, look, what I can do is that I know this thing for sure that every edge is being visited twice. So why not I will just return that sum of the I will calculate all the W1 from till Wn, and I will just multiply it by 2 and say that this is the minimum cost. Now, how just take a pause on this section of the video and just think for yourself that whether this is the right answer or not. Because I'll just repeat myself, or you can just this is a YouTube video, so obviously you can just go back and watch it again. But anyways, overall what we are doing over here is that we are just traversing the whole path again and again. But do you think this is the minimum traversal thing? So the answer is actually no, because see, the question says that we need to visit all the nodes of the tree. So if we had, but while going ahead from this node to this node, let's say that we reach point G, do you think it makes a sense that we go back to node A? No, right? That is the twist in this question. That is the catch in this question. So I will just try to make you understand again what we had just done. So when you have visited all the nodes from A to B, B to C, then you go back to B, then you reach D, then you reached A, and afterwards you went to E, and then you go to F, then you reached E, and then you reached G from E. So in this way, you have covered all the paths. You have visited all the nodes, right? So this is our actual minimum because we do not need to return back to the A. Now, one thing you need to answer is that how do we ensure that this is the minimum? This is the minimum distance traveled. Like, how do we ensure that path we need to exclude the path from A to G, or we have to exclude the path from A to F? How do we ensure that? So to do that, what you need to do? Think. Now the weighted concept will come into the picture. What will happen apparently is that now my W1, W2, let's say that I will just give some number now so that it becomes very clear to you. Or let's take a very simple example from A to B to C. Now let's say this was 10 and this was 5. Okay. Now what do you think? How would we would have done the traversal? First, we would have gone from A to C. Let's take this scenario. We went to A to C. The cost was 5. Then we went from C to A. The cost was 5. Then we went from A to B. The cost was 10 again. So the total cost becomes 20. Now let's take another scenario where we started from A, then we visited B first. The cost is 10. Then we return back. The cost is 10. Okay. Here, here only our cost has hidden a value of 20 total 20, and we have to visit the node C as well. So the total cost will be what? 25, and 25 is greater than 20. That means we have to exclude the path on which we get the maximum cost. Again, so if for some reason we will select the path from A to some node which will give me maximum cost, and while doing this we are ensuring that we are not returning back to that root node, right? So what would happen is that we have traveled from all these nodes and we reach the some maximum node, this, and from this maximum node we say that okay, I'm done, I do not need to go anywhere from this point onwards. That's a pause. So I hope you understood the answer. The coding is very simple, it's nothing fancy. So the edges I have just represented, we're using the int 2. This is the int2. That means that this is directing to the node B, and the weight associated is given in long integer. This is initialization, and the next thing over here is that this is the main code of the given problem. So you can see over here is that we have first created a in this given question, you will be, let's say that it is given in the format of from and to. So you will be given you are given from, to, and weight. So from using that you need to construct the tree. Actually it's not a tree if you think about it, right? Because it's an undirected thing, so it becomes a graph at the end of the day. So if it's a graph, then you create an adjacency list. Now in the adjacency list we need to do a DFS traversal. Now in the DFS traversal, what we just need to do is that we need to store the we first of all, as you know, that we need to find the maximum sum, right? But in the DFS traversal, what we can simply do is that we can start from the node 0 and we can go to we can do the DFS traversal for the entire this undirected graph. Now if all we need to do is that we need to check for a node with the maximum value, right? Once we have completed the entire DFS for this thing, Now all the values which will be stored, so this will be the, where is my value? Yeah, this is the distance, right? So this distance, or you can say the weighted sum. So from A to B it will W1, from A to C it will be W1 plus W2, something like that. It will be stored at the end of the day. Now once you have done the entire traversal, the each given node over here will store the actual cost and right. And what we need to do is that we need to figure out that maximum value from this distance. We just subtract from the sum. Now what is sum over here? As I earlier told you that we are traversing each node or each edge actually twice. So apparently what we need to do is that we need to multiply all the weighted values, and we have to multiply it by 2, and after that we have to subtract it with the maximum value of the distance. So thanks guys, that's all about it. So I hope you like this format. If you have any suggestion, please do comment, and I'm always open to improvements. I know this is my initial start of the YouTube journey to explain cool concepts or very fundamental concepts to the, and breaking down in the as smallest as possible, smallest units, so that it's actually easily understood by in any students who is trying to get into the DSA or starting its journey in the world of computer science. So thanks.